One day, Christy Ashwandon, a science journalist, took her camera and went to a statistics congress to ask the speakers, "What is the p-value?"
In statistics, you try to estimate if what you think is there.
To me, the most telling answer in that video was Steve Goodman, who said, I've been studying this p-values my entire career, and even I can't tell you.
Now, we ask Christy, as a revenge on the part of the scientists.
Oh, you want to ask me what a p-value is? P-values are, oh gosh, I would like to just pass on this. I'm smart enough to know that I cannot I cannot define a p-value in a simple sentence that will be satisfying or easy to understand.
Well done. The truth is that it is difficult to explain, in a simple way, without resorting to its definition. What is the p-value? Try it by yourself.
The reason that I wanted to do this video, I got the idea to do it because I realized that this is a universally difficult thing, that it's not just lay people or journalists who have trouble explaining what the p-value is, but that even scientists and statisticians and people who think about this stuff all the time really struggle to define it in one sentence or to make it simple.
We ask to our scientific advisor.
Lo que el p-valor dice, de acuerdo con la teoría estadística, es ¿cuál sería la probabilidad de encontrar una muestra de características como la que yo tengo que arrojara una evidencia más contraria a la hipótesis que estoy contrastando que la muestra que yo tengo?
And finally, we asked Ronald Wasserstein, who is the executive director of the American Statistical Association.
The p-value is the simplest way that I would say it is it's a way to measure how compatible, or more specifically, how incompatible our data are with some statistical model that has been specified.
This video is just going to try to get an idea of what the p-value is not.
Y en cambio he oído decir cosas como que el p-valor me dice cuál es la probabilidad de que la hipótesis nula sea correcta. Falso. Pero he oído muchas otras cosas, que no tienen nada que ver, como la probabilidad de que la hipótesis alternativa sea falsa. Bueno, es un desastre.
In any introductory statistics course, we have learned the basics of hypothesis testing. For example, we have two populations, Madrid and Castilla, and we want to find out if the difference in the average math grade of 10-year-old kids is different or not in both populations. To do this, we take a random sample, let's say 100 elements in each population, and we work with the data. It is common to ask if the difference in means, in our case 0.4 points, turns out to be 0 in the population, compared to the alternative that there is a positive difference, and we say significant. We establish, then, the null hypothesis and the alternative. According to the definition of p-value, as you can see, it consists of
Sería la probabilidad de encontrar una muestra de características como la que yo tengo que arrojara una evidencia más contraria a la hipótesis que estoy contrastando que la muestra que yo tengo.
In this case, the null hypothesis is that the difference of the means is 0. We must look for this probability, which turns out to be 1.6%. It is said that, since it is less than the usual significance level of 5%, we reject the null, and then conclude that the difference in population averages is non-zero. Now, do you think it is a difference, on average, of 0.4 points large enough? If you notice, the p-value depends on several factors. On the one hand, in the numerator, the difference of the sample value compared to that of the hypothesis that, in our case, is 0.4. On the other hand, the sample variances and the sample size, that give us an idea of the precision with which we are operating. For instance, if the sample variances had been greater, the p-value would also have been higher, and we would not have rejected the null. The same would have happened if the sample had been smaller, Do you begin to intuit how a p-value can be manipulated? Can you see certain holes in the orthodox work with the p-value?
Ortodoxia, entre comillas, imperante, es únicamente ortodoxia porque impera, no porque sea deseable, es, a mi juicio, lamentablemente, el análisis paramétrico, que a su vez utiliza de manera excesiva y superexhaustiva y muchas veces incorrecta la contrastación de hipótesis paramétricas.
It's hard to find a scientific paper or data-driven work that does not focus on which null hypotheses are rejected at 5%, which variables are significant, or, they say, relevant, based solely on p-value. However, for some time now, many prestigious scientists are drawing attention to this way of working. The first of these, in fact, was the inventor of p-value. Fisher, around 1925, thought of it as an informal way of evaluating the discrepancy of the data, with a model or null hypothesis assumed by the scientist. Nothing to do with current usage. This other book has a rather provocative title, The Cult of Statistical Significance, and says things like,
the use of statistical significance, sort of throwing all of statistics out with it, sort of making the argument that statistics is somehow the cause of these problems and not the misuse of statistics being the cause of the problem.
And let's look, for example, at this other paper published in Nature. More than 800 researchers, including Valentine Amrine, rise up against the p-value. According to them, using the p-value in scientific decision-making impoverish it.
People very often just say, here's one effect, so that might be an average, and the other is here, and they are the same because it's statistically non-significant. And this is just, I mean, they are not usually the same. And this is a big problem if, for example, the people who publish that claim that the drug, for example, has no side effects because the side effects are statistically non-significant.
Contraste de hipótesis se hacen a determinados niveles de significación o de confianza, del 1, del 5, del 10%, que alguien, hay una tradición en estadística, pero a mí nunca me ha resultado convincente y no soy el único en esto, nunca le ha parecido suficientemente justificada.
People really want them to tell us whether the result is correct or not, right? That's what people are looking at. Well, the p-value is under this value, so we can trust it, or we can't trust it. And the p-value simply can't do that.
In fact, we might ask ourselves, what does it mean that something is statistically significant?
Significant has different meanings. And for statistically significant, it means that the p-value should be lower than a certain threshold. But you also have practically significant, and that means that the effect is large enough that you can accomplish things that you would really like in practice, and that it has some meaning.
Yo sí creo que hay lo que se llama un p-hacking, un secuestro del p-valor. No solamente por los investigadores, sino incentivado por los editores. No te publican un artículo si el parámetro no es significativo. Y yo creo que ahí perdemos un poco el norte. Hay muchas veces que es más importante que algo no sea significativo. Si tú estás estudiando el efecto del salario mínimo sobre la inflación, por decir un ejemplo, y te sale que no influye, eso es más importante, no que buscar un p-valor.
Let's think about a medical treatment that must be analyzed with data, its effectiveness.
So this is not about statistics. This is about information that people in the field have to give us.
If the treatment is very expensive, surely you will not only be interested in the impact being statistically significant, but you will be interested to know that it has a real impact on the population.
Otherwise, we will not implement the treatment anyway when this effect is not large because it's too expensive.
Shouldn't you then consider the cost of treatment versus its benefit?
So this has to involve arguments out of practice. There is where practitioners and statistics come together.
It is time for us to tell you that the ASA, the American Statistical Association, decided in 2016 to open a can of worms and publish a very celebrated guide on what is and what is not a p-value.
Matter of the culture of science improperly using p-values. And this is why, the American Statistical Association actually came out with this statement.
There is really a movement of many, many different people, and that's really not just us. That's also the American Statistical Association published this famous p-value statement in 2016, and so we say 3 times in the commentary that we are not arguing against using the p-value, but only about this dichotomous interpretation.
Scientists who are demonstrating against the use that is being made of p-value. Like a good trilogy, the first episode shows the conflict of the story. Do not miss the next. We are going to the American Statistical Association.